Okay, so I'm trying to unleash my inner Vi-hard on this one. I've got my piecewise defined function at the left. I've got my handout printed from my website here, and ready to go with a plethora of Sharpies. Here we go. Whenever I introduce piecewise defined functions to my students, I usually have them disregard the domain on these altogether and just try and graph the functions individually, and then of course put them together in pieces like the name says. And what we're going to end up doing with this one is creating a foldable out of it. So I'm going to take one side of the graph and actually fold it over to the other, and therefore create one continuous function. So here's what it's going to look like in this case. On the left side, the function that I'm trying to be concerned with is just going to be y equals, or f of x equals 2x minus 1. And then plotting a few points in there with no regard for the domain that's going to be specified later. I just have them fill in the table. So there, -3, -2, -1, 0, 1, and 2. Pretty good sampling of points on there. If I evaluate these real quick, middle plot, decent collection of them. Get a good feel for what that graph's going to look like on the whole. And then trying something different for the other piece over here. On the opposite side, I need to graph the other piece of our function, which is just y equals, or g of x equals the opposite of x plus 3. And then collecting a sample of values there, -3, -2, -1, 0, 1, 2, and 3, because I haven't yet, at this point, emphasized what the domain is going to be later on our piecewise defined function. So our students are able to concoct the graph on the whole and not really see any difference between what we had done in the past and what we're doing as a new feature with piecewise defined functions. So graphing those. Getting the resulting graph as it pertains to what we're looking for. So 2 graphs, no pieces, no nothing. Just 2 graphs. And then when we start dragging the domain into it, x less than or equal to -2, well, that's where I left the space down at the very bottom of this handout. If x is less than or equal to -2, the only place on this graph where I really want to pay attention is everything from this dashed green line to the left. So there's all the stuff that I want to keep. Yay! On the other side of the graph, where x is greater than -2. So everything on that same dashed line and to the right. Yay. So with those 2 pieces there, the emphasis that we place then is how do we include the endpoints at -2 in both instances. Well, if it's got the underscore with it, or we actually include x equal to -2 in our domain over here, we actually need a closed circle to indicate that. So for big point of emphasis there, I put a big old closed circle. Over here, if we lack the underscore, or it's not actually equal to -2 in this case, what we had done with just single variable inequalities was used an open circle, or a parenthesis if we were doing it in interval notation. But now taking those 2 graphs there, actually sandwiching one right on top of the other, my students are able to see what our piecewise defined function is going to look like. They're able to raise questions about, well, is it supposed to be continuous? Are we supposed to be able to draw this as one continuous streak on our graph? And things of that nature. So there's how I do foldables and teach a 2-piece piecewise defined function.